Greetings. We're discussing the drug reviews notebook, and we've made our way through most of the pre-processing. Some of this is really sort of leading into the actual model development. We've got this, we had the PCA variables that I wasn't very impressed by because there are many of them and we don't know what they mean, so not necessarily going to be all that helpful. And then I noticed that, the relative importance of many of the features is about the same. The ones that we may drop out based on this analysis, this is on incidentally feature importance from a random forest classifier, is the ones that are relatively unimportant to the subjectivity of the review and the condition that the drug is being used to treat. And the others are, so the most important ones are the date and the useful count. So we're going to split the data into in a holdout sample. X1 train, X1 test are the predictors, and Y1 train and Y1 test are the target values for the training and test set. And the training data is 7955 instances in magnitude. We're going to push the training data, that is X1 train and Y1 train, through synthetic minority oversampling to balance the data. And the reason for that was when we did a dot describe somewhere earlier, hopefully, let me just see if I can find that for you. There was some data imbalance. And if I don't have it, I'd probably have to rerun it for you. Maybe I didn't actually run the dot describe, but there was something like a 45 to 55% imbalance. I guess I didn't run that, so apologies on that. We might be able to just run it here. Well, now it's well, I guess we could run it on X, right? Okay, so where is our, okay, so I need Y mean, sorry. Yeah, it's 48.8 to 51.2%. So almost balanced, and doing this mode, not all that important. If you wanted to pick off, the top several features, you could use this recursive feature importance. Here we're selecting 5. So when you run this again using that random forest classifier, these are the ones that would show up as important. Also got some scaling going on here of X1 train. So I just ran that. And then, the big next step is to build some classifiers. So PyCaret is our low code option. And I'm calling this pretty much with no hyperparameters. I mean, the only thing I'm doing is specifying the data frame, which I'm just concatenating X and Y there, and then using the targeted rating. So it goes and does a sort of an out of the box horse race across different classifiers, and you can see which ones they are. GBC, LGBM, RF, extra trees, gradient extreme gradient boosting, edit boost, LDA, quadratic discriminant, naive Bayes, KNN, logistic, decision tree, the dummy SVM, and the rich classifier. And it scores these presumably out of the box. I'm using AUC as the metric, and so I'm interested in the GBC classifier. And then it goes ahead and tunes the model. So it figures the base model, and then it tunes that model and then evaluates it. And what we get then is a sort of a 10-fold evaluation of the GBC classifier. Its performance is roughly consistent. It seems to be varying from about 63% accuracy, or if you look at the AUC metrics, some of the numbers, 63 up to what, 66. So relatively low variation. And we get a learning curve, which shows up down here, which shows that we're a little overfitted. There's about a 6%, 5% difference between the performance of the classifier on the training data and the test data. More training, since these things are sloping, a larger sample size beyond the 10,000 may get us there. We may also, need to peel off a variable that could help. And then there's a move that I want to make with the date that could help. So I will show you that in sort of the next iteration. On our little holdout sample, I'm showing you a confusion matrix. The results shown for that are a little, well, I guess they are consistent with some of the numbers we're getting here. accuracy in about the 63% range, right? So 361 false positives, 369 false negatives, as opposed to about 1,250 correctly classified instances there. Now, we just have the decision boundary here to see that it's really a pretty complex object for human consumption. That's just features 1 and 2, whatever they may be. So it would be hard to sort of pick through the decision boundaries and make much sense of that. I want to move on and discuss the horse race using code classifiers next. So I'll just end this clip here and we'll move on with that.